Hi, it's Mr. Doro. Today we're going to be talking about reaction stoichiometry some more. We're going to add on to our mole ratio problems, and we're going to add one more aspect in. And so by the end of this video, I'm hoping that you can do a proper action line, converting from mass of one substance to moles of another substance. The most important detail of using mass in stoichiometry is to make sure that whenever we're changing from one substance to another, we're using mole ratios. If we're given mass, we're going to have to change that mass over to moles first, just like it says right here, and then we can use our mole ratio to change it over to the other substance. Well, the first thing we have to do is remember how to convert to moles from grams. So I've given you a problem here, given grams, 21.6 grams of sodium is how many moles of sodium. And so remember, in order to do this, we have to use an action line. And so we start out our action line with our 21.6 grams of Na, and then we copy down grams of Na down here, and then we can go right from grams to moles of Na. Now whenever we do this, we're always going to put a 1 in when we're going from moles to grams or grams to moles. But how do we get the grams? Well, we got to look at our periodic table. And so I brought our periodic table up and back right here. And so remember, if we look at sodium right here, up in the corner, this is the molar mass, which means grams per mole. And that says 22.99. So I'm going to put 22.99 grams of sodium per 1 mole of sodium. And then I just calculate that out. And when I calculate that, I get 0.940 moles of Na. Now, we're not going to stop there from now on, but we just got to remember that this is the process to go from grams to moles. I want to remind you again about finding molar mass. You need your periodic table to do this, so I got a few compounds that we're going to work out here. Calcium, you have to look that one up first of all, and calcium, when you look it up, you're going to find out that it is 40.08. There's only one calcium because there's no subscripts after it, but then we have to add to it these chlorines, and so since we're going to a new element, I'm going to add to it chlorine, which is 35.45, but there are 2 chlorines from this subscript right here, and so we need to multiply this by 2, and then we calculate that out. And that is 110.98 grams per mole. Now, if you don't know where I'm getting these numbers from, just rewind it a little bit and look at your periodic table, and it's just copying those numbers over. For H2O, we got 2 H's, and that is 2 then times 1.01 plus oxygen, which is 16.00, and that ends up being 18.02 grams. For sodium sulfate, we have 2 sodiums, and so that is 22.99, that's each sodium, times 2, plus, now I'm going to a new element, sulfur, which is 32.07, plus oxygen, which is 16.00, but there are 4 of those, so I'm going to multiply that by 4. I'm going to put it in my calculator just the way it shows right here. And I get 142.05. This is something that you need to know, how to find the molar mass. If you don't know how to do it, then plug them in, try some extra ones. Try these ones again on your own. Go back, rewind it, and try them before I did it. One of the things we have to recognize is when we're going to use a mass to mole problem. So we're going to use this when we're given a mass, and I've just put of x right here, and x could be anything in a balanced equation, and we're asked to find the moles. So we're given mass of x, we're asked to find the moles of something different, of y. So here's an example, and I'll show you where this all comes into play. This is what a generic action line for a mole or mass to mole problem is going to look like each time. So I want you to write this down in your notes. I haven't written any numbers inside of here, but if we're given the mass of x, that's going to be grams of x, and that's what we start out our action line with. Then we're going to copy down the grams of x and then change that over to moles of x. Now, in order to do this step right here, we have to use the molar mass. And so when we do this, this one right here is going to be molar mass, which we get from the periodic table. And this is always going to be 1 mole for the number of grams of X, whatever that is. And then we notice how I had to stay with X here each time. And then I copy down my moles of X. Here's my mole ratio that I can use from the balanced chemical equation. And I get these numbers from the coefficients, matching them up exactly with Y and X, whatever they are. So when I look at my example problem right here, I've been given 26.9 grams of magnesium. That would go right up here in this area, 26.9 grams of magnesium. Then I would put my grams of magnesium down here, then go up to 1 mole of magnesium, which, by the way, the grams I would get from the molar mass from the periodic table. And then from my balanced chemical equation, I could change from moles of magnesium to moles of, this is what I'm looking to find, magnesium oxide right up here on the top. So we're going to go ahead and try to work this problem out. It says how many moles of magnesium oxide are produced. Now, I didn't talk about this with sufficient oxygen. What that means is just you've got plenty of oxygen. Just like if you were going to make cookies and you had a 5-pound bag of chocolate chips, you look at that and you say, oh, I got plenty of chocolate chips. And so that doesn't really matter. You have enough in order to make this reaction happen. So what we're going to start out with every time is a balanced chemical equation. I'd like you to pause this right now and try to see if you can balance the chemical equation on your own. Go ahead. Okay, you were supposed to pause it there. I don't know if you did or not, but if you didn't, then you should have. This is the skeleton equation. Now, for real this time, go ahead and pause it and balance this equation. There, that's better. Okay, now, if we don't start with a balanced equation, we don't have a correct recipe. So we need to make sure that we have the balanced equation first of all every time. Okay, so now what we're going to do is we're going to make an action line, and we're going to change this 26.9 grams of magnesium. That's what we're given. We're given this in the problem, 26.9 grams of magnesium. That's where I start my action line. So, starting out with 26.9 grams of Mg. I want you writing the Mg down there too, because we're going to be switching back and forth here later on. We know that we copy down grams of Mg, and we're going to get that grams of Mg from the periodic table. And then we're going to change it over to moles. We always have to go to moles first. If we're given grams, change to moles. This is going to be 1 mole, and then we're going to go over here, copy down moles of Mg. And now that we're at moles of Mg, we can go anywhere on this balanced equation that we want to, because this says 2 moles of Mg react with 1 mole of O2 to make 2 moles of MgO. And so when we plug it in here, we can go to moles of what the problem asks us to find. It says how many moles of MgO, magnesium oxide. So I'm going to moles of MgO. Go where the problem tells you. By the way, this is 24.31 from your periodic table. And then this is from the balanced equation. We get 2 moles. Here it is right up here. 2 moles of Mg. I'm copying it right down. That's why I put the Mg on there. And then MgO, we got 2 moles also. So this is 2 to 2. So now we go through with our calculator. Oh, by the way, these are going to cancel out. Grams of Mg are gone. Moles of Mg are gone. We're left over with moles of MgO, which is what we want. So now we go 26.9 times 1 if you want to, divided by 24.31 times 2 divided by 2, which would cancel out, but plug them in anyways. Okay, this is the answer that I got on my calculator. You should be plugging it in yours. Check up on me. Make sure I'm doing it right. Now I got to check my sig figs. I've got 3 sig figs right here. This is a exact quantity, so I don't need, that doesn't affect my sig figs. I've got 4 sig figs there. I need my answer in 3 sig figs. That means this one's my first one. The 1 and the 0, I look at this one to see if I round up or not, and I do. So my answer is going to be 1.11 moles of MgO. So that's how I do, and then put a box around it. So that's how you do a mass to mole problem. Okay, there are 2 problems that I want you to do on your own. This one I've helped you out with. I've given you the balanced equation already. You're looking to find how many moles of potassium chlorate you need to decompose to make 61.3 grams of oxygen gas. So you should be showing an action line, and if you did everything correctly, then you should get 1.28 moles of KClO3. So set up that action line, pause it, figure it out, and then go to the next problem. Okay, I want you to try this one out now. Now you're going to have to write the correct equation for this, and I want you to remember oxygen is diatomic. Check the charges when you write aluminum oxide. It's just aluminum plus oxygen produces aluminum oxide. And then I want you to balance the equation properly and construct the proper action line. I've put the answer down here on the bottom for you to check out. If you're not getting this answer and you're getting very frustrated, you might want to check out your molar mass for aluminum oxide, which I got to be 101.96. So that's a common mistake that people make. But check this out and have it done and be ready to turn it in. Hope you have a great night. Bye-bye.